Do you want to sound like a genuine fancy pants mathematician? Then why not say to someone, "Would you like me to prove Pythagoras' theorem for you?" If they answer yes, then don't panic. By the end of this video, you'll be a proper expert in Pythagoras' theorem and you'll know how to use it. In this video, we will start from scratch and build up from nothing to the formula you might already know as a squared plus b squared equals c squared. We'll also learn how we can use this formula to solve questions. By the end, you'll be eager to show off all of your newfound knowledge to all of your friends. Possibly. This video involves a story. Are you sitting comfortably? Then let's begin. So, this is the not exactly true story of little Peter Pythagoras and his bedroom window. It was a lovely, big and square window, but it let in too much light. Peter had some black card to block out the light, but all he had was 4 identical pieces, all in the shape of a right-angled triangle. He put the first in the bottom corner of the window. With the second, he rotated it 90 degrees and found that it fit nicely in the top corner, making a right angle with the first piece. He repeated this process by rotating the third piece and placing it in the top corner. And finally, the pattern was completed by rotating the fourth piece and placing it in the remaining corner. Now this didn't block out all the light. There was a square area of glass not covered by the black card. The length of the sides of this square was the same as the long side, or hypotenuse, of the triangle. Let's call this length C. This means that the square area of glass not covered is C times C, which is C squared. Little Pete Pythagoras realised that because he couldn't make the black card any larger, there would always be a constant area of uncovered glass for the light to come through. But he decided to have a bit of fun anyway, rearranging his pieces of card. He rotated one triangle to make a rectangle, then another triangle to make another rectangle, and he moved this one to the top of the window. This left him with 2 squares of uncovered glass, a small one and a medium one. He could see that the small square had the same side length as the shortest side of the black triangle. Let's call this A. This means the area of the small square of glass is A squared. And then there was this medium square of glass. The side length of this square was the same as the middle side of the triangle. Let's call this B, making the area of this bit of glass equal to B squared. So, in total, this new pattern of black card means that the total area of uncovered glass is the sum of the 2 squares, which is A squared plus B squared. And, because little Pete realised the triangles have not got any bigger or smaller, the total area of uncovered glass has not changed and must be the same for both patterns. And therefore, A squared plus B squared equals C squared. Amazing! In fact, this formula had been known for over 1,000 years beforehand, but little Pete Pythagoras had been able to prove it with shapes, which may or may not have involved his bedroom window. Incidentally, my bedroom window is huge, which is great, but it's a massive pain to clean. So, now you know the background to the formula and why it works, let's try it with some questions. It's important to remember that Pythagoras' theorem only works with right-angled triangles, or rats as I call them. And here's a quick tip when you're confronted with geometry questions. If the question is asking for a length, and the only other information you have in the question is length values, then there's a good chance it could be a Pythagoras question. If the question asks for an angle, or angle values are provided as information, then it's more likely to involve trigonometry or angle rules, which we cover in other videos. So, let's try some Pythagoras examples. Here are 3 questions. Pause the video and see if you can work out lengths x, y and z, and once you have answers for all three, I'll step through the solutions with you. So pause the video now. The first one is the simplest. We use our Pythagoras formula of a squared plus b squared equals c squared, and always remember that c is our longest side, which is the hypotenuse of the triangle. Let's label the sides. It really doesn't matter what you label as a and b, as long as c is the longest one. We can now plug some numbers into our formula. In this case, we have side a equals 3, side b equals 4, and side c is our hypotenuse, which is length x. So our formula becomes 3 squared plus 4 squared equals x squared, which is 9 plus 16 equals x squared, which is 25. However, the question asks for x, not x squared, so we need to square root both sides. The square root of x squared is x, and the square root of 25 is 5, and we have our answer, x equals 5. On to question 2, which is very similar. If we label the sides of our triangle A, B and C again, the formula becomes y squared plus 5 squared equals 13 squared. This becomes y squared plus 25 equals 13 times 13, which is 169, and we want the y on its own on the left-hand side. So to do this, we need to minus 25 from both sides. Y squared plus 25 minus 25 is y squared, and 169 minus 25 is 144. Like the previous question, we now need to square root both sides to get our answer. The square root of y squared is y, and the square root of 144 is 12, so we have our final answer. Those two were nice, simple, clean questions. Question 3 is a bit trickier. With this one, the diagram is a little different to the others, but there's no need to panic. Let's look at the information we have. We only have length values in the question, not angles, which suggests that this is likely a Pythagoras question. We also know that Pythagoras uses right-angled triangle, remember our rats, and this triangle is not right-angled, although we can see it is symmetrical because these two sides are the same length. We are asked for length z, which is the height of the triangle. If we actually draw this height line from the top of the triangle, we can see we have now split the original triangle straight down the middle into two right-angled triangles. And this is a very common method in questions. Break down shapes into right-angled triangles in order to solve the question. So, in our Pythagoras equation of a squared plus b squared equals c squared, a can be our height here, which is z. B squared is this bottom side. We don't immediately know the length of this, but because our triangle is symmetrical and we've split it straight down the middle, we know that b is length 7. And c is our long side, which is 18. So our initial formula is z squared plus 7 squared is 18 squared. This simplifies to z squared plus 49 equals 18 times 18, which is 324. I didn't do that in my head, by the way. We want z on its own, so subtracting 49 from each side gives us z squared on the left and 324 minus 49, which is 275 on the right. And finally, square rooting both sides gives us z equals 16.583124. But the question asks us to write our answer to 1 decimal place. So this becomes 16.6, and we are done. I hope those explanations all made sense to you. If not, just let me know in the comments, and remember to like and subscribe to the channel so you don't miss out on future videos. To improve with these sorts of Pythagoras questions, try to get comfortable using the square root button on your calculator and always look for those opportunities to break a shape down into right-angled triangles. Look for the rats. If you've got the taste for triangles, check out the other videos in our geometry playlist, and I'll see you there. Thanks for watching. Until next time, I'll see thee.